NASA mission to study mysterious neutron stars, aid in deep space navigation. A new NASA mission is headed for the International Space Station next month to observe one of the strangest observable objects in the universe. Launching June 1, the Neutron Star Interior Composition Explorer, NICER, will be installed aboard the space station as the first mission dedicated to studying neutron stars, a type of collapsed star that is so dense scientists are unsure how matter behaves deep inside it. A neutron star begins its life as a star between about 7 and 20 times the mass of our Sun. When this type of star runs out of fuel, it collapses under its own weight, crushing its core and triggering a supernova explosion. What remains is an ultra-dense sphere only about 12 miles, 20 kilometers, across, the size of a city, but with up to twice the mass of our Sun squeezed inside. On Earth, 1 teaspoon of neutron star matter would weigh 1 billion tons. If you took Mount Everest and squeezed it into something like a sugar cube, that's the kind of density we're talking about, said Keith Gendreau, the principal investigator for NICER at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Because neutron stars are so dense, scientists are uncertain how matter behaves in their interiors. In everyday experience, objects are composed of atoms. When neutron stars form, their atoms become crushed together and merge. As a result, the bulk of a neutron star is made up of tightly packed subatomic particles, primarily neutrons, as well as protons and electrons, in various states. NICER measurements will help scientists better understand how matter behaves in this environment. As soon as you go below the surface of a neutron star, the pressures and densities rise extremely rapidly, and soon you're in an environment that you can't produce in any lab on Earth, said Columbia University research scientist Slavko Bogdanov, who leads the NICER Light Curve Modeling Group. The only object known to be denser than a neutron star is its dark cousin, the black hole. A black hole forms when a star more than approximately 20 times the mass of our Sun collapses. A black hole's powerful gravity establishes a barrier known as an event horizon, which prevents direct observation. So scientists turn to neutron stars to study matter at nature's most extreme observable limit. Neutron stars represent a natural density limit for stable matter that you can't exceed without becoming a black hole, said Goddard's Zavan Arzoumanian, NICER deputy principal investigator and science lead. We don't know what happens to matter near this maximum density. In order to study this limit, NICER will observe rapidly rotating neutron stars, also known as pulsars. These stars can rotate hundreds of times per second, faster than the blades of a household blender. Pulsars also possess enormously strong magnetic fields, trillions of times stronger than Earth's. The combination of fast rotation and strong magnetism accelerates particles to nearly the speed of light. Some of these particles follow the magnetic field to the surface, raining down on the magnetic poles and heating them until they form so-called hot spots that glow brightly in X-ray light. NICER is designed to see the X-ray emission from those hot spots, Arzoumanian said. As the spots sweep toward us, we see more intensity as they move into our sight line and less as they move out, brightening and dimming hundreds of times each second. A neutron star's gravity is so strong it warps space-time, the fabric of the cosmos, distorting our view of the star's surface and its sweeping hot spots. NICER will measure brightness changes related to these distortions as the star spins. This will allow scientists to determine the pulsar's radius, a key measurement needed to fully understand its interior structure. Once we have a measure of the mass and radius, we can tie those results directly into the nuclear physics of what goes on when you compress so much mass into such a small volume, Arzu Umanian said. In addition to understanding how neutron stars are put together, NICER's observations will also help scientists better understand the critical mass a star must achieve before it can turn into a black hole. This is particularly important in systems where neutron stars orbit another star, allowing them to pull material off the companion star and gain more mass. The more neutron stars we observe at high masses, the higher the mass threshold becomes for a star turning into a black hole, said NICER science team member Alice Harding at Goddard. Understanding what that critical mass is will help us determine how many black holes and neutron stars there are in the universe. NICER will also provide scientists and technologists with a unique opportunity to make advances in deep space navigation. Its X-ray measurements will record the arrival times of pulses from each neutron star it observes, using the regular emissions of pulsars as ultra-precise cosmic clocks, rivaling the accuracy of atomic clocks such as those used inside GPS satellites. Built-in flight software, developed for the Station Explorer for X-ray timing and navigation technology, Sextant, demonstration, can see how the predicted arrival of X-ray pulses from a given neutron star changes as NICER moves in its orbit. The difference between expected and actual arrival times allows Sextant to determine NICER's orbit solely by observing pulsars. Although spacecraft in Earth orbit use the same GPS system that helps drivers navigate on the ground, there's no equivalent system available for spacecraft traveling far beyond Earth. Unlike GPS satellites, which just orbit around Earth, pulsars are distributed across our galaxy, said Jason Mitchell, the Sextant project manager at Goddard. So we can use them to form a GPS-like system that can support spacecraft navigation throughout the solar system, enabling deep space exploration in the future. Installation on the space station provides scientists and technologists with an opportunity to develop a multi-purpose mission on an established platform. With the NICER Sextant mission, we have an excellent opportunity to use the International Space Station to demonstrate technology that will lead us into the outer solar system and beyond, and tell us about some of the most exciting objects in the sky, Gendreau said. NICER is an astrophysics mission of opportunity within NASA's Explorer program, which provides frequent flight opportunities for world-class scientific investigations from space utilizing innovative, streamlined and efficient management approaches within the heliophysics and astrophysics science areas. NASA's Space Technology Mission Directorate supports the Sextant component of the mission, demonstrating pulsar-based spacecraft navigation.